Thank you. So we can share and we can come back to this video if you need to, right?
Sure, yeah.
Perfect. So let me introduce myself. My name is Mohammed. I'm based in New Jersey. We are a big database consulting company. We have been working in the industry for last 4 to 5 years. Compared to that, my company is pretty new. We just started this company like 1.5 years ago. We've been mainly focusing on financial companies in East Coast, like in New York, New Jersey. So we have so many financial companies. They have their headquarters based in New York, New Jersey areas, and we have been helping them to get their business the benefit of Hadoop and big data, right?
Right.
So before I go into deeper, right? So my presentation will be more of a theoretical conversation, but I will just for touch basis, I will just explain a very high level how Hadoop works. I know everybody of us know it, but just for any audience who are not aware of Hadoop and big data, how it works. So I will just touch the technology a little bit, right?
Yeah.
So we have a training wing also.
Yes, Mohammed, just to interrupt, would you share this presentation with us?
Yeah, I don't mind to share. That should not be a problem.
Okay,
Okay.
please continue.
Sure. So we have a training wing also. I do train people. I have one of my colleague who uh, train people on the development side too. But the development side training is mainly ran from India. We have an offshore team, like we have a partner offshore team who are helping us in training. So based on the US, anyone wants to train, we help them to get trained. Okay. So that's
Okay.
the background. So let me start with the digital technical part, right? So there's a very
Yeah.
big confusion. So people say big data and people say Hadoop and how they're related, right? So all this
Right.
technology belongs to the NoSQL family, right? So
Right.
NoSQL family has been evolving for last 10 years, 10, 12 years. And from that family, Apache Hadoop was born, Apache HBase was born, Cassandra, MongoDB, right? So there are so many other NoSQL based company. So as we talk big data, we are basically meaning almost all these families, but we are mainly focused on Apache Hadoop and Apache HBase product, right? So just to
Okay.
clarify, so we'll be mostly when we're talking about big data, we'll be mainly focusing on Apache Hadoop and Apache HBase. Okay.
Okay.
Now, the very first question, right? Every business has its own data. So how can I determine whether my data is big data or not? If you're struggling to manage your data, if it is too big for your analysis or too big to handle it, so you are almost in a big data area, right? So that's when you have to realize, okay, this is the big data, and we have to start a better platform to handle this data, right? These are a very few example. This is just global example we use in every conversation. So like Walmart, like the largest, I would say, largest superstore in the world, they are making 1 million transaction every hour. So this kind of company, they are using this technology to handle this kind of transaction and store them and process them and do analytics on them, right? Facebook, everybody has a Facebook account, and they have been working with like billions of users, and they have been generating billions of different sort of data and storing them in their platform. So these are the company who are using them. So this will give you an idea like how big the scale of big data is, just to give an idea. So big data symptom, like how big is data, like let's say if you have multiple databases and all of the databases is reaching more than 500 gigabyte, 800 gigabyte, or say 1 terabyte, right? Typical RDBMS, typical SQL Server, MySQL, Oracle, they are not uh, mean to run analytics job on them. So they are very good at storing data, running your TSQL job, running your update, and all the OLAP, right? I'm sorry, OLTP transactions, right? But when it comes to analytics, generating report on top of them, right? That's the point they do struggle, right? So if it is your like production server, you don't want to run like hour long jobs on those databases. It will be consuming all your resources. Your production job will be slower, right? So that's the point that we are reaching. If a company, if a client is reaching to that point, then that's the realization point that okay, my data is getting growing very big. I need to move to a bigger platform, right? Okay, so let me move on. And please feel free to ask me any question and just interrupt me. I'm fine with that. So we call them three V's. If you are meeting any of these three V, you are ready to start your big data journey. So volume, if your data is in high volume, like almost terabyte or like half of the terabyte, and you need a platform to analyze them. Velocity, you are generating the data very fast. The speed of your data generation is too fast. You need a platform to store them. And of course, when you're storing, the end goal of storing any data is analyzing them, right? So when your data is being generated very fast, you need a platform to store them right in real time and maybe analyzing them at a later point. Variety, so not only relational databases like tsv, csv, xml, not only those formal and structured data, right? If you are handling or if you are working with log data, you are trying to make sense out of your logs. And not only log, let's say you are trying to make sense of your social media feed. You're trying to perform some real-time joining on your existing databases on top of your social media data, right? Those are the variety of data that you are handling with, right? This is the point that you have to move to different database, a different data platform which is big enough to do this sort of jobs, right? So these are the three V that we see as a symptom. If you are hitting any of this, you are almost on the first step of your big data journey. Anyone any questions so far?
No, it's okay. So far, so good.
Perfect. So who has invented them, right? So the main idea of this big data and NoSQL and big table has been developed by Google. Cassandra MongoDB family has been coming from Facebook, and Yahoo. So these three big companies, they has a very big user base, and they needed the platform to handle this huge amount of data, and they come up with this idea of big data, right? They open sourced it. So after that, all the company like they are just enjoying the open source community, right? Now here's the one thing, right? When we say open source is supported by the community. Most of the open source projects are supported by the community, but there are a few companies who has came forward and helping this open source community to gain the momentum, right? So big companies like any big company, big bank, right? They don't want to use any open source company where there is no support, right? So they want one responsible person who will take the responsibility of your support, and they can use open source, right? So for Hadoop specifically, there are two companies. One of them is called Cloudera, and another one is called Hortonworks. They came forward, they took the responsibility of the support and says, okay, you know what, you can use these open source tools. Going forward, if you have any issue, we will be responsible for supporting them, and you have to pay me this much of money yearly, monthly, per server, right? So there is a support, paid support, but still the software is open source. So you can use it for your production level job. If you don't need support, then you don't have to pay. If you need support, then you have to pay to the companies, right? So that's the whole scenario of open source community regarding big data. So big data has been growing a lot. There's been statistics like the big data job has been uh, in the market, like it has increased about 4 to 500 times, and the growth is expected until like 2022, right? So the growth should be continuing like this every year. There are like new jobs are coming in, and new companies are picking this technology, and the job market is very very high. Who are using this? Almost 90% of the Fortune 500 companies. So Fortune 500 company, they are steering the IT business or a financial business in the entire world, and they are 90% of the company, they are using big data for their daily use cases. So you are in good hands. And why people are using it? Because of the variety of data. So in a personal level, right, let's say 10 years ago, or let's say 5 years ago, the capacity of my cell phone was like 8 gigabyte or maybe 16 gigabyte. Nowadays we are using 128 gigabyte, 1256 gigabyte of data phone, and there are running out of memory. So at a personal level, we can see the data generation or the data growth for personal level has grown a lot, and so is true for the for the all the industries too, right? The type of different type of data has been growing, the size of the data has been growing, and they need a bigger platform for this. The very first question, why is so popular? Because it is meant to be open source and it is cutting your cost almost 50 to 80%. So this 50 to 80% is not regarding all the is not related to the licensing, but also for the hardware. If you have a hardware like very commodity hardware, like let's say you have a server with 16 gig of RAM, a couple of CPU, you can start using big data. So this technology is being meant for commodity hardware, which are not costly, which are not very high end. You can start your business. You can start your use case on those hardware also. It's widely supported by community, as I was saying, is open source, is been supported by very big companies, even Microsoft, IBM, HP, they are also contributing these projects. And if you have any problem, if you're not having a paid service, paid support, you still have a lot of resources to go through and troubleshoot your current issues, right? And very big driving point for this technology is the adaptability, because you can just use your existing Java job, Python job, or maybe SQL, which are already running in your different databases. You can just ship and pick them and ship and run in Hadoop platform. Hadoop platform is being supported by all these major languages. So there are like around like 200 different tools that you can use with Hadoop, which are supporting either Java, Python, Rail, Ruby. There are so many other languages which is supported by Java, which is supported by Hadoop. So you can pick any of them. So most likely, if you have an analytics job which is being written in different language, uh, you are most likely can ship your job to Hadoop with some obviously some minor tuning and minor changes, right? Now, this is just a theoretical thing, right? Now, how it works. So the basis of Hadoop is like distribution, right? So if you're storing a data, let's say you are creating a cluster with 5 nodes, 5 servers. If you're uploading or if you're storing any data into this platform, the data will be distributed among these 5 servers. When you need to perform any job on top of this data, when you're submitting a job, let's say you are submitting a Python job, the job will be again distributed and the job will be ran on those 5 servers. So we are at the same time distributing the storage layer and also the computing layer. If you're familiar with the supercomputing concept, right, that is almost the same. Like they're distributing the calculation, the computing processing in a wide range of number of servers. This is the same concept, but just being used for the storage and computation. And for these purposes, you don't need a very high-end supercomputers, right? You just need like hardware, like commodity hardware, which can be bought in the normal market, right? So that's how it works. So it has a layer called HDFS, which is responsible for storage layer, and it has a MapReduce layer, which is responsible for your computing. So this is a very high level, like 1,000 feet overview of Hadoop. Now here is a very bold statement. I would say one of the widely used, I would say 80 to 90% of the use cases with Hadoop is data lake. We are all familiar with the concept of data warehouse. So what is a data warehouse? So data warehouse where you put all of your data of your enterprise in a single place. So you are buying one very high-end data warehouse tool with the hardware and the software, and you are putting all your SQL like structured data in that, right? So that is what we call data warehouse. From data warehouse, you are running your analytics job, all your reporting, all your BI tool, and all your maybe data scientists are pulling data from data warehouse and running their own analytics on them, right? So that's what the data warehouse is. Now, data lake is a very comparatively very new concept. So data lake is being used for not only structured data, which is already covered by data warehouse. It is also used for storing semi-structured and unstructured data. Semi-structured data which needs some cleaning to make it structured. unstructured data, just like your log, server log, or your any device log, right? So those are unstructured data you can store in data lake. The very fundamental difference of data warehouse and data lake: to store a data in your data warehouse, you need to define your database, your table, and the schema. Only then you can write your data into a data warehouse. On the other hand, if you are building your data lake with the Hadoop technology, you don't need to define your schema before writing. You can just dump it whenever you need it. Then you are defining your schema, saying, okay, this is my table, this is my data, and I
So
have.
I have a question for you.
Yes.
I mean, in a data lake, how do you store them? Is it on a container, or how do you do that? The
So
schema.
the schema.
Yeah, how do you store the schema?
So for schema management, right, we use RDBMS. Let's say MySQL. All the schema will be stored in a MySQL database. Whenever you call the data from the schema point of view, you will look at as a table. When you want to
Okay.
access the data as a file, you will be accessing the data as a file, just like as in a Linux box. So that
Okay.
means Hadoop file system is very much like your Linux file system. You are saving a file, you are doing cat, you are doing ls, ld, cp, all the thing you can do in Hadoop. I'm sorry, Linux. You can do almost everything in the Hadoop file system too. You can say cp file from here to there. You can say du, the size of the file, right? You can do everything, every operation, just like Linux and the Hadoop too. But when you need to look at the data as a table, you can call that schema saying, hey, this is my table, this is the schema, these are the name of the column, these are the type of the column, and here's the data. Show me the data in a table format. And that's when you can look at the same data in a table format. Does it make sense?
Yes, it does.
Okay, perfect. So storage hierarchy, in data warehouse, we store the data as a hierarchy manner. So we are storing the data as a database. On the database, we have multiple tables. In the tables, we have maybe partition, right? All these hierarchies there. On the data lake, we store the data as a file, just like your Linux file system, right? So you're just writing the data as a file. When you're trying to look at the data in a table format, there are tools which will help you to look at as a table format. I will go in detail in few minutes. Give me a few more minutes, okay?
Yeah.
So when you say agility, right? So in data warehouse, you don't have very much option. You have to be structured. It has to be schema defined before you write the data, right? In that agility perspective, Hadoop has better agility. You just write it. You can configure. You can reconfigure. You can delete your schema, define a new schema, but data will remain the same. So here's a, you have a agility. Now the security piece of it, right? When you compare your data warehouse with the data lake, the security has a little bit. I would say it is catching up with the data warehouse standards. As of today, 2018 July, you can provide column level security to your data. So you're storing your data. Let's say you are storing a CSV file. On top of that file, you are creating a table. If you're doing the same thing in data warehouse, you can also say, okay, this user will not be able to see my this row. All the other row he will be able to see, but this row he won't be able to see. So this is a row level security. But on the Hadoop side, as of today, only column level is possible. So you cannot say, okay, this user cannot see my this column, and you can do that. So this is the, I would say, the granular difference between data lake and data warehouse in terms of security. Other than this, you can use Kerberos, you can say database level, table level, all those security measures are already available in data lake or Hadoop environment, right? So that is taken care. Now the user base is not correct in my slide. It says the data scientists are main user, but the use cases has evolved. All the business user can use that. Now I'll take one more minute to talk about data lake and why data lake is so important, right? The name itself has a deeper meaning. So if you look at my screen, right, This is my
Yeah.
favorite slide. What is a data lake and how come it has get the name, right? So if you look at the lake, this is the Lake Superior. It is on the border of US and Canada. The right side corner of it is the Niagara Fall. Okay, why we use this slide on explaining of data lake? If you look
Yeah,
at,
because you love Canada, right?
I know I love USA actually. So why we use this? So if you look at a lake, not only this lake, any lake which has a larger presence, right?
Like Pulshan Lake.
Gulshan Lake, I really loved it, but it's very small anyway. So the comparison between lake data lake and lake is, in a lake you will see a variety kind of species. That means you will have like a water vegetation, different type of fish, and different type of in depth, I would say depth, right? If you look at the screen, it has red, green and blue color, right? It means the temperature of the water. So if you see at the very end, at the very on the edge, you will see the waters are warmer than the central. What does that mean? How does it replicate your data warehouse, a data lake? So data warehouse is widely used for storing historical data also. So there is another classification of data. So data can be classified as structured and unstructured, and another way of defining data is cold data, warm data, and hot data. So the data we use every day for our analysis, we call them hot data. The data we are using once in a month, maybe we call warm data. And the data, the historical data, maybe we are using once in a year or maybe once in a couple of years, right? We call them cold data, right? In data warehouse, if you're storing your historical data, that is very costly because you are just bearing your data just for historical purpose. You cannot delete them, but you are just paying the very high cost of your data storage.
Right.
The same purpose can be served in a data lake in a very way cheaper cost because of the hardware capacity, right? You are just using a normal hardware. So let's say you have a client who has a huge amount of historical data. They
Right.
want to just store the data just for regulation purpose, for example, right?
Right.
What you want to do,
Which is most of the case in financial industry.
you have to store the data for certain years, right?
Right.
That's the thing,
Right.
right? So in that case, you will build some server which has more storage, less compute. Whenever you need to access those data, which is very rare, you can access those data. Your data is very close to your computing. If you need to run some analysis, you can run them, but that is a very high dense of storage. You are not doing so much of computing, and that's why you're not adding so much computation power to the server, right? On the other hand, so let's say you have a client who has a lot of hot data. They want to just run those data very fast analytics, right? You can also store those data in data lake. So data lake is serving the both purpose in a right manner and in a, I would say, in a mature way, so that you are not losing the computation and you are also not losing the high storage, right? Another aspect of data lake, right? So if you look at the lake, it can be accessed by all the side. That means if you have a business user from coming from all around the business, marketing, finance, risk, whatever your department is, right? You can give them access to your Hadoop cluster. Even we have worked with a couple of clients who are taking requests from the end user. They have hundreds of users. They are using mobile apps. They're submitting requests, and this service is served by the Hadoop cluster. Hundreds of users can be served by this cluster. If you have a huge amount of data and you want to respond to this request quickly, right? You can do that. So this is the concept of data lake. So if you're familiar with data warehouse, if you're looking for a cheaper solution, data lake is a very good solution. Now, there's a very big misunderstanding. People are saying data lake is trying to replace data warehouse, which is not true. Let me show you one slide here, right? So this is a very common practice. So you have a very costly data warehouse system, and your data is growing. Now you have to maintain your budget at the same time. You don't want to expand your data warehouse again like infinitely, right? You have to manage it. So you want to offload some job, rather than expanding it, you just want to offload some job. How can you do that? Let's say you just want to offload your historical data and some of the hot data to a Hadoop cluster. After that, uh, instead of giving your BI tool or any analytics tool to connect to your warehouse, you are redirecting those tools to get the data from Hadoop. This is how you are not only getting a helping hand in terms of computation, but you are also saving a lot of money in terms of storage and computation on the warehouse system. Warehouse systems are like the SAP ERP, right? Very costly system. If you're comparing SAP to Hadoop, you are looking at like 70% or to like at least 40% cheaper solution. This is a very good example where you can coexist. You can have both of your good thing at the same time, and they can help each other. You have another job which is very high priority. You don't want to move to Hadoop. Okay, let's run it on the warehouse system. If the data warehouse needs some data from Hadoop, they can also connect to each other. They can pull the historical data to warehouse and they can run it, right? So vice versa, they can work and help each other. So this is the coexistence system. You don't want to replace anything, but you can get
That's
the
a
best
great.
out of both. Any question?
Thanks. No, thank you.
So I have some more slide. Okay, let me show you this, right? So data lifecycle, how the data is being generated, how we ingest the data to the cluster, how we do manipulation, what are my options, and how the data is being consumed, right? So in this slide, I'm trying to give an essence of how what type of data you can store. Like your data is being generated from sensors or mobile data, machine logs, tabular logs. So mostly used for tabular data. Tabular data means that you are having some data in your SQL Server, Oracle. You just want to ingest them into Hadoop cluster. You can do that. Email, social, telemetry, anything you can store in Hadoop system. Now the ingestion tools, right? There are a wide range of open source ingestion tools come with your Hadoop platform. You don't have to pay those high costly ETL tools for your ingestion. You can have like multiple ingestion tools which comes with your open source, and you can use those open source tools to connect to your existing system or maybe some devices, and you can ingest this data directly into your Hadoop platform. After you ingest the data, you can run different sort of analytics on them. You can do the cleaning, governance, and whatever policy you want to apply on them. After that, you can have this data for your searching purposes, accessing purposes, or reporting purposes. There's a wide range of user you can serve with this data, right? So this is the high level data flow, data lifecycle. Now here comes the business. Manjuvari, can you hear me?
We can hear you well. No
Perfect,
problem.
perfect. So this is the business part of the conversation, right? How this can be offered to your cluster, offered to your clients. So I'm this conversation is mostly focusing on your current business. Whatever information I can get out from your website and from the internet, I have just uh, added my estimation or like speculation on top of that, and I'm just giving you a proposal, right? So try to correct me if I'm wrong in some way. So these deployments, like whatever I'm talking about, the Hadoop cluster, it can be deployed in couple of manner. One is pseudo cluster. That means for development purpose, you don't want to have a wide range of like 10, 12 server just for your development purpose. You can have a pseudo cluster. That means you'll be installing all the tool in a single Linux box, and you will have access to all those open technology, as I was just saying, right? You will have all those technology, you will have access to all those languages for your development. After the development is done, then you can move your code to a real cluster where you run your QA or UAT or whatever testing you want to run to move forward for production, right? So this is the pseudo cluster. On premise, so customer has their own data center, they want to run it on install their cluster on their own data center, they're welcome to do that. A very popular practice is deploying on the public cloud. So in US we have AWS, Microsoft, Google, right? Is also available in Bangladesh. So everybody is deploying their
Do you
cluster.
know something?
Yes.
Do you know something that we did a cost calculation between on-premise, in fact, our own private cloud versus the public cloud. Public cloud is much more expensive than we do it ourselves.
Oh, that's a good thing to know. That's a good thing to know. So
Yeah,
so many
because
companies.
also it has got a lot of bandwidth limitation, number of user limitation. So in an application which has got rapid user base enhancement, going to a public cloud is actually much more expensive, and it does a lot of very unpredictable things. So, for example, if there is a high traffic started to come, they'll lock you out of the account,
I agree with you, and people have been complaining
and
about
you
it.
get business loss. In fact, we are about to lose a huge business because of their this, and you have nobody to talk. Everything is machine. So it's
Exactly.
not that you can pick up phone and tell people that guys, I'm suffering. There's no.
Exactly.
So
I,
3 day my application was locked. A bank was locked without any transaction. That
okay.
sort of thing they do. So these days, whenever people talk about anything to do with public cloud, we immediately reject them.
I agree with you. So we have customers who have been complaining about public cloud a lot, right? They have been losing their entire cluster for a couple of hours for critical business, and they have been losing like billions of dollars. And the SLA has been written in a way that they're always saving the public cloud, so they have nothing to do, right? I
Yeah,
completely agree with you, and that's where your private cloud comes into the picture, right? So
right.
if you can afford a private cloud of your own, you are very welcome to do that. And people are deploying their Hadoop cluster on the
We
private
are
cloud too.
we are doing. We have a tier three data center here.
Okay, perfect. So that's where I'll be talking about in few slides. So give me 1 minute. And another practice, let me finish my slide. So another practice is a hybrid. So you have your data on premise, but you don't want to spend capital expenses. I mean capital investment on your new hardware. You are just creating your cluster on the cloud for development purpose or POC purposes, transferring the data from your on-premise, running your job, you are seeing success, then you are deploying your cluster on-premise and running the same logic, everything, right? So these are the deployment model I just want to share with you, right? So we're good with that. Now here comes to your very business specific use case. So who are your potential customers? Your potential customers could be, let's say you have, I'm sure like you have so many users for your data center. They're renting your servers, they're running different type of business, different type of data is being stored in those, right? So you have to, let's say if I were in your show, let's say I'm trying to develop a business with your company, right? What would I do? I would say, okay, let's identify some of the customers who are struggling with the data size. They're hitting, let's say, couple of hundred of gigabyte. Their analytics jobs are running for hours. Before we go for right, so we'll be only talking about OLAP use cases, no OLTP. Hadoop is not meant for OLTP transactions. We are not supposed to run or store any OLTP transaction on Hadoop data. We'll be only talking about OLAP use cases where you have your data already there. You don't need to update them, but you need to run analysis on them, right? We'll be talking about OLAP use cases. Okay.
Right.
So let's say you will be identifying, let's say, okay, these are my top 10 customer who has this amount of data. Let's say all of them has more than 500 gigabyte of data. They have OLAP use cases. They need to run some daily job or weekly job or monthly job, right? And those jobs are running for hours, like 10 hours, 12 hours, okay? So this is your first target, I would say. Now the data scientist, right? So data scientist, you can run you in your own computer. You don't need a bigger cluster. But when you need to train your data, or you need to make a more accurate prediction models, right? How would you train your data? You can train your data with the gigabyte of file that you have in a personal computer, or maybe you have a bigger computer, you have like a couple of gigabyte of data, right? You can train your data science model, prediction model on your personal computer too. But to make it more accurate, to make it or train it with a terabyte size of data, what you have to do? You have to move it to a bigger platform which can store, not only store terabyte of data, but it can also run data science job on terabyte of data, right? And that's called Hadoop. Streaming use cases. Let's say you have a customer or you have a potential customer who want to store their real-time data in a platform. Maybe some what do you call this, IoT, right? IoT based company, they want to store the data. They don't have the infrastructure to store that huge amount of data. They want to store the data. That's what your customer is, right? Business intelligence, just like the example I just showed you, right? The enterprise data warehousing system, you want to don't if you want to offload some of the workload from that, that's where you can introduce Hadoop platform to offload some of the data. You have users who are using artificial intelligence, machine learning, which needs a lot of data to train them, right, to make decision on top of the huge amount of data. Let's be very specific to machine learning, right? Machine learning needs more training. You have 100 gigabyte of data, you are splitting into 70/30. You are using the 70% to train the data, 30% to test your probability, right? How about
Right.
training the data with the 10 terabyte of data? I'm assuming your like theoretically your prediction will be more accurate if you're training with more data, right? And
Right.
that's when you have to move to a bigger platform, and that's where Hadoop comes in, and that's why people are using Hadoop for machine learning in a wide range. I just can't explain how much people have been using for machine learning data. So this is your potential customer. I'm just giving a hint. I'm sure you know business more than me, just to give you like a very high level idea where you should be looking starting at, right? So this is your potential customer. Now, other than this, right? I'm sure like if you're offering the big data to your customer, they're not gonna say yes at the first meeting, right? How are you gonna convince them? So this is just very personal proposal from me to you and your company. Is like, let's create one multi-tenant customer cluster. What would be a multi-tenant cluster? In this cluster, you will give the access to multiple users. Let's say you have identified five potential customers. They have a huge amount of data and they want to try it, but they don't want to invest it. They don't want to commit to your company. Okay, I'll be creating a big data cluster for a couple of years. So they don't want to go to that commitment. How you want to do that? So this is the exact model that I have helped one of my clients. So they wanted to have a playing ground for their potential customers. So what you're gonna do? You're gonna create one cluster with maybe 6 to 10 node, depending on your number of potential customer. It will have around 30 open source tools for ingestion, for data scientist practices, for developing different languages, let's say Python, Spark, data scientist, ML, right? Machine learning libraries, right? It will have all those open source tools to support your different use cases. Exactly these use cases will be supported, or maybe more than that. After that, the multiple potential tenants will be given access. So those tenants will onboard your data to this cluster. They will play with it. They will try to make some benefit, like business benefit out of the data and the platform. When they are happy with their outcome, they can move to their own independent cluster. So this is the phase two. Now, how you can make the money? So you are giving a playground and you are asking your customers to try out their use cases on this platform, and the the money will be charged how much space they're using. So we'll be building a chargeback model. There'll be a chargeback model. In this chargeback model, you can see, okay, this user is storing let's say 200 gigabyte of data, and they have been using this much of RAM and this much of CPU in past 30 days, and you will have your own calculation of charging them, right? So for this amount of resource utilization and storage utilization, you will be giving me this much of money. So this is your chargeback dashboard. So you will, of course, even with a with this playground, you are making money, and the most important thing is that you are giving the flavor of the big data to your customer. And if they are successful, and you will be successful too. This platform will be supporting a wide range of use cases, as I just gave you an idea, OLAP, data science, and everything. It will be supported. And once the use cases matures or the data grows, or let's say customer is satisfied with the platform stability, let's say, right? They just want to host their historical data into the cluster. So they are very welcome to have their own cluster, and all the security will be there, right? So let's say one of your client is coming in and say, hey, I like your cluster, but my business use case is to use a different tool which is not present in your computer in your cluster. How can I do that? So we will try to evaluate those requests and see if it is feasible for the platform. We can install them and let them use them, right? So this platform can be and has to be monitored and maintained at least 24/7 if you have multiple users. I'm assuming all of them are not your native, like not from Dhaka, maybe from international clients. So you're proposing this platform to them and they're using it. So it has to be maintained for 24 hours 7 or whatever SLA you have with your clients, right? This class this is a minimum size you can have. So you can have a 5 node cluster. This storage capacity and the CPU and RAM can be tweaked. So storage capacity, let's start with 20 terabyte. You want to add more hard disks, you are welcome to do that with this 5 server. You will have around 40 vcore. Just a note, this is a vcore, it's not core, so it's like virtualized. So you are basically having 20 CPUs and you are just virtualizing them to make it 40, and you can have 40 processors at the same time. You will have 80 gig of RAM, and operating system will be using C++7, right? Same to C++7, which is also open source. So this is the multi-tenant cluster configuration. So let's say we complete our first phase one successfully, then what next? The next step would be for each user will be an independent cluster of their own where they can use as much as they want and how much they pay you, they can use that. So minimum cluster you'll be requiring, this is just a standard practice to have 5 node. You can define your own minimum, and the maximum also has to be defined by from the data center perspective, right? So you have to define the maximum size. So the cluster has to be very customized. So let's say you are mostly having OLAP use case. You wants to make sure your infrastructure is uh, well tuned for OLAP functions, not very storage heavy or not very compute heavy. You just want to have this balance. You have a client who just wants to store the historical data. You want to have a storage heavy or storage dense cluster. So those are the things that will be considered when you're creating a cluster. A whiteboard session will be done. So let's say a customer is coming and saying, okay, I'm trying to go for a real-time ingestion use case. What are the tools we will need? Every use case will be unique. Every client will have their unique requirement, and we will sit with them. We will go through all the possible tools and all the possible hurdles they will have in future, right? So these are the phase two. The summary of phase two is like everything will be custom for this particular user. Whatever they need, we will try to accommodate, right? And the SLA. So the main part of this business is like the managed service, right? So all this, we are assuming all this cluster will be hosted in your data center. You will be not providing the Hadoop support, but also the managed service support. That means OS layer, hardware layer, anything, any issue, you'll be managing them, and you'll be paid for those, right? Now here is the shared responsibility, right? The thing we're talking about, the model we're talking about is comes under platform as a service, right? So we have a software as a service, we have an infrastructure as a service. This particular use case or this particular proposal is based on platform as a service. So you're providing Hadoop platform to your cluster, to your customer, and they're just utilizing that. And you'll be taking most of the burdens, right? You'll be taking care of the software, hardware, and the platform. You don't want to give the platform control to your client because they're very new. The technology is new in the country. You don't want to give the access right away to them. If they are well educated and you think they can manage, or they think they can manage, you are welcome to do that too, right? Now here's a shared responsibility. So here, if you're looking at my screen, so the yellow mark, my company logo has a yellow, so that's why I'm using yellow, and your company has a blue logo, so I'm just using the blue to mark your responsibility here. So here we will be starting from the top to bottom. So the top is like the use case analysis. We don't know whether this use case is suitable for big data or not. So we will be like, from my company point of view, we'll be starting from that point of view. We'll be talking to the customer, what are you trying to do, how can we help you, and is it really a good solution for you or not, right? Okay, we agree, okay, this is a great solution for you, okay, let's go ahead. Now, designing this infrastructure, I just gave you example. If you're storing just historical data, a cluster will be different, the hardware will be different, the tools will be different, right? If you're having most of OLAP use cases, the infrastructure will be different, right? I'm sorry, that would be that is my bad. Okay. The third option would be deployment of the infrastructure. That would be like from your data center guys who will be deploying the hardwares. After that, the deployment of the platform will be responsibility of ours. Manju, can you hear me?
Yeah.
So I was trying to explain you the responsibility, right? So we'll be discussing, we'll be designing the infrastructure, how the cluster should look like, how many server there should be, what should be the configuration of the server, right? We'll be designing those, and the deployment will be done by, let's say, your data center people. They'll be deploying the server, the operating system, all the Linux operating system and everything. If you have your own native monitoring tools, you'll be installing them, right? All the standard protocol you have to follow, right? You have to do that. After that, the server's access will be given to us. We'll be deploying the cluster. We'll be installing all the required tools. We'll be also doing the fine tuning. So let's say hardwares are different, so the configuration has to be unique in each cluster. So we'll be doing everything. After that, we'll be handing it to the cluster a customer. They'll be starting using it, and the maintenance, the managed service part of it has will be taken care by, of course, your team, right? So this is my proposed shared responsibility. We will be, going forward, we'll be discussing in depth of this. When it comes to troubleshooting, right? That's the catchy point at this point. So let's say you have a wide range of system admin. They're very good at Linux, right? But this is a very new platform from them. What can you do? How are you gonna troubleshoot? And this is your learning process, so you have to invest on your resources to get them trained. So you have to, let's say you are selecting 2 to 3 people and getting them trained in Hadoop at a very high level, or whatever level you think is suitable. You just training them.
But we
And when
already have Hadoop trained Hadoop team which has implemented couple of Hadoop applications.
okay, that's done, that's perfect, right? I'm not sure, is it a managed service platform that you are
It has
making?
our own application.
Okay, okay. So I'm not sure how new it is for you, right? So this is my proposal that I have for you. If
Okay.
you think, if you see any potential in this, we can discuss further, and we can, do some
Okay. Let me get back to my team. You send me this presentation over. So I will get back to you in 3 days time by Tuesday.
that should be perfect for me. That's not a problem. But do you have any comment? Do you want to discuss
No,
something?
it's okay. I mean, I was trying to consume your ideas, what you have in your mind. Looks like interesting, but we have to look at how to package this opportunity and take it to market together.
Sounds cool.
Okay.
Do you think any other potential use case that we should be covering?
And let me also think it over. This was the first meeting, so let me consume everything. You send me this over. I'll have some of my own research, and let's talk again on sometime on Tuesday. You'll hear it from us.
Perfect. That sounds cool. So we will wait for your response then.
Sure, yeah. So I'll wait for this material.
Let me send it in few minutes. It has some more slides, but you can just ignore them.
Okay, okay. Sure.
Yeah, you can just ignore them. That shouldn't be a problem. Okay.
Yeah.
Thanks a lot, Manju bhai, for joining us, and that is a very good discussion. And we'll be waiting for your